Good afternoon, everybody, because we're real afternoon. If you don't understand, just stop me, because I have a funny accent. Even my wife, who's British, doesn't always understand me. Okay, like he says, I'm Keitapu Maamaatuaiahutapu. Yeah, some people will say, oh, that's how ridiculous. I have one of my friends who told me how ridiculous your name is. But that has a meaning. I have a French name, it's called Richard. I don't know. I know only you can't be rich with that name, but I'm actually poor. Okay, I'm from University of French Polynesia. You see this picture? This is a picture taken from my university. You also welcome to come and study in French Polynesia. It's far cheaper than here in terms of fees. So this is, yes, just to show you how beautiful our islands, and those who haven't been to islands, and then how water is, pristine water is, and so, some of the people have seen them. And we see how the nuclear things will come and change all this, because we don't see the nuclear pollution. Okay, radioactive pollution is not visible. Okay, so my talk is mostly about climate change and nuclear risk and in French Polynesia. I will mostly talk about where the French test happened in French Polynesia. Okay. Before I start, I'd like to introduce you to this guy, Bruno Barrio. He's been helping us in French Polynesia, and he's been working on all finding all the documents and fighting with the French government to get all the details about the test, because we, maybe it's the same case here in the US. All these experiments which has been carried on in a nuclear test, it's very difficult to get the information, and it's still they're still disclosed by the French government, so it's not open to any scientist or whoever. So, and this guy, it's mostly I wanted to introduce it to him, because his struggle is not only between French Polynesia and the French government. It's more on a wider scale. And the problem is that he only speaks French, and his struggle is really fight against the nuclear disaster that's happening on the planet. So it's not limited to our case. So, and one of the books he wrote is this one, called The Bomb and Us, and of course it's in French. So he's an interesting guy, and he helped me with some documents I will present you today. Yeah. Since we're talking about climate change and nuclear risk, I just, before going into details, just quickly, so we come back on that, and in the conclusions are, well, we all know about nuclear risk. We know that it's a power of destruction. If all the countries now decide to explode their bombs, we won't see the sun anymore, and the Earth will cool down. Some scientists have been working on that. I mean, some scientists from the US and Russian as well. And what will happen if everybody explodes a bomb now, nuclear bomb? It's the end of us. All together, even us far away. Because the whole Earth will be darkened, and the sun, won't be enough heat to come on the Earth, and then will be cooled down. We know, I'm sure you know about the radioactivity. It's a long-term pollution, and the biggest disaster behind is mostly the disease that we can call, and the number of cancer have increased. Of other disease, I mean, mostly by those who have been exposed to radiation, their future generation might have problem. And in our case, we can have land destruction, because they do destroy the land, and part of the land are no more usable for anything. And what that has to do with climate change. It's true in the US you have big continent, you can't always escape to the mountains. But you see that picture behind? That's the atoll where it's an atoll, low-lying atoll, island. This is where the test happened. So it's really at sea level. So the climate change, if there is a sea level rise, so there's enhanced erosion, and then inside of these lagoons where the test happened, you have pollution. I will show you a map later of the pollution in this lagoon. And all this polluted material inside will come to the ocean. What will happen then? Of course, nothing inside this lagoon. There are fishes. Nothing is edible at this time. Because as you see, the half-life of plutonium is 24,000 years. We won't be here anyway to see when it will be clean. I would say so. So sea level rise has an importance for this island. And of course, in climate change, there's a common saying among, I would say, climatologists that, with the global warming, we have more and more cyclones occurring on the planet. And it's also happened on these islands in French Polynesia. So I will start talking about French Polynesia, just to introduce first where is French Polynesia, and then talk about the French test. There were some protests as well. I decided at first to stay very factual, and then yesterday I wrote that slide on the protest. Because I wanted just to give you facts and not to bias my talk and be passionate about it. So I just want you to have your own judgment about things that happen there. And then we talk about the underground test and the radioactivity pollution, and that include also because you have atmospheric test and the underground test, and you have potential pollution from both. And then the climate change impact at the end. Okay, so this is a map of the South Pacific. So French Polynesia is right here. And you see all these are the EEZ of some states, some territories of US, French, and the Brits, and British territories. So there are some independent states, I won't name them. So French Polynesia is you see that most of the islands, occupy the center of the South Pacific. Okay. And French Polynesia has the biggest EEZ. And it's about 5 million square kilometers. So this is all the islands in French Polynesia. So 5 million square kilometers, it's the size of Europe. And this is half of the EEZ of the French, of France, because we're part of France. So, and you have different islands. So you have the Austral Islands, and the southernmost part of French Polynesia here. And then you have the Society Island, where this Tahiti, where we have the capital, if you want. And then you have the Tuamotu and the Gambier. Tuamotu, you see Moruroa is here. It's where the test happened. And you have the Marquesas. There are about, I will say, I don't exactly know. We do speak about 5-6 languages there, right? All Polynesian, but different. You have the Marquesans is different from the Tahitian in Tahiti. You have in the Tuamotu a different language, and the Gambia is different language as well. But we can understand each other. Number of atolls is 100 18, and most of the Tuamotu is this line here. They are atolls. Where the test happens is it happens on atolls. Okay. And the actual population is 300,000 people. We're not that many for a big space like that. You might say it's just water. Yeah. Yeah, I just wanted to show you this map. They're showing the distance. No, okay, Moruroa. Yeah. Yeah, sometimes there's two writings. This is the Tahitian one, Moruroa, and Moruroa is the French one. We used to do that one, that's why I just keep my way. Okay, so just for you not to be confused, it's exactly the same. The distance from these islands to the continent. I mean, I'll show you this map. It's just because when Fukushima, when Fukushima happened, the radioactive leak in Fukushima, and then I think the US people from the United States were panicking, so the same for Europe. It's quite a long distance. Huh? But when that thing happened, it's more an anecdote I'd like to tell you. When it happens, because there's big panic in France as well, so that was the first time they sent us iodine tablets. But when the test happened, we didn't have iodine tablets. It's just to let you know how things have changed, and it's completely different now. So now coming to the French test, there are about 210 tests. You might say it's a lot. No, the US have done more than 1,000 tests, a nuclear test. Okay, so but still, it's still a lot. Still a lot. So the French test, just a bit of history here, started in Algeria, okay, in the 60s. And when Algeria became independent, and then the French government has to find another site. Of course, they couldn't make it in France. They couldn't do it in France. But they tried to have it in Corsica, because at that time they already knew how to do the test underground, but the Corsican didn't want it because they also know how to make bombs. So there's a big protest in France. And finally they found French Polynesia. It's big enough. You have a lot of islands, and some of them are inhabited, or very few people on them. And so it's easy to move those people away from the island. So, and this started in reality well before the 60s, because at that time the French President de Gaulle knew that Algeria would become a big problem. They couldn't keep Algeria, because Algeria was a colony of France. They couldn't keep Algeria. So in the 50s, they started the process to, they've been in contact with people in Tahiti. And in 58, the president of France decided to set up a referendum to ask the people if they would like to stay French or no. And at that time, one leader, Polynesian leader, fought against France and went to do a campaign to vote for the no to the French. Of course, he lost because he only have a canoe. He paddled from island to island to do his politics, but it didn't work. So, and then we stayed with France. So and then the French decided that we have to they have to have two islands, and they decided with some political leaders in French Polynesia, to get those two islands. So it's more of a gift. We gave France those two islands. So our political leaders at that time gave those islands. But you might say, why did they give them? I will tell you, they had no choice. It was that or a military government in French Polynesia. So no choice there. So that's why in 1964, those two islands have been is part of French Polynesia. I mean, we are French, we're French as well actually, but those ones, it's really France property. The local government can't say anything, cannot say a word on that, on those islands. And in terms of tests, so in 1966, the atmospheric test started. So 2nd of July 1966, that was the first bomb. And between 66 and 74, more than about 46 atmospheric tests have been done. And I wrote here, 4 on the raft. So when it's exploded on the raft, generally the raft is just in the lagoon. So when it explodes, all the waste and the detritus from the bomb just falls in the lagoon. You have 34 on the aircraft. So it's just a bit higher, not completely out of the atmosphere, and free in the plane. Most of the fallouts of the bomb just fall down because, it's plutonium, uranium, all those are heavy metal, are heavy. So they quickly fall on the ground. Even though the French government for a while have been saying, no, it's not, it's moving elsewhere, outside. But we'll talk about that later. And what happened in 1964, and generally when they do their test, I'll just come back to the map. When they do their test here in Moruroa, they say generally that the wind is blowing eastward, and so all the bad things coming from the bomb is drifting to the east. This is what they say. Unfortunately, in 1974, it didn't happen like they said. It went westward. But we didn't have any mean to check where all those, polluted things is going. If it's going westward or eastward, the meteorology is all controlled by the French government. So we have no way to know where it's really going. And in 1975, they started to do underground tests. You might think it's safer, but I'll demonstrate. We'll see that it's not. It's as worse as the other one. Because the other one, we are contaminated straight away because it's in the atmosphere, like we've seen for Fukushima. And underground tests are also dangerous because it happens here on Atoll. Okay, so they did 147 underground tests, and mostly in Moruroa and 1 atoll, and 8 in Fangataufa. Fangataufa is just nearby Moruroa. In 1992, the French president, that was Mitterrand, stopped the test. And in 1994, there was a new election and the president changed. That was Jacques Chirac, and he decided to resume with tests. So 8 tests has been done after he decided to resume. And only in 1996, the test ends. Yeah, like I said, but I already talked about it partially, about the protest, because it didn't go that smoothly even for the French government. In 1958, as I told you, there was a referendum imposed by de Gaulle the then president of France, and the leader who contested the referendum is Povana, and the same year has been deported because he was very influential of people, and the French government is seeing him as a danger for their project. So he's been in prison in France for more than 10 years. I mean, just taken away from the land. But it did not stop. There was political action against those nuclear tests, and then they're still from the same party as Povana, the leader Povana. There were some new people coming in, like the deputy Teriki, who gave a speech to the great French government. But only in 1970 there was international protest, because in the 1960 there was already an agreement, I think, between the US, Great Britain and Russia to stop the nuclear test. I think that was in the 1960s. But you see, well after, the French discovered the bomb very late, but they wanted to be a big power like the others, so they needed a bomb. That's the objective of the goal. And in 1970, there was an international protest, because mostly from those countries around, and like I said, when the wind is blowing eastward, so all the remnant from the explosion is going to South America. And Chileans have started discovering that number of people having cancer there is increasing. And so that's why they joined the protest, and with Australia and New Zealand. But they wrote to the International Court, but that did not stop anything, because the French just went on, because with their explosion in the atmospheric test till 1974 before they started underground. And then there was some march in Papeete in 1973. And in 1977, a new political party for independence is Mr. Oscar Temaru, and he decided to create his own party for independence, and also to fight against the French test. So he's been a lot involved with Greenpeace as well, and like we see in 1985, there was the Rainbow Virus, which has been sunk in Auckland, and Oscar Temaru was there, but luckily he wasn't on the ship at that time, because I think 2 persons died on that in this event here. And in 1995, when the new president, Jacques Chirac, decided to resume with tests, there was the burning of the town of Papeete. And I remember some of my American friends, mostly researchers, who were supposed to come here. Isn't it dangerous to come to your place? No, that's our history. That's our business, nothing to do with other people. So, and only in 1996, Greenpeace decided to come to Moruroa. I just go quickly through all this. So, I would like now more to talk about underground tests, so you can realize how that can be dangerous for an atoll. Okay, you see, those are the 2 atolls where the test happened. You see the land is just around, and all this land is coral or sand. So it's very fragile. You know, some corals, you can't just take it and break it like this. Imagine when there is a bomb and the whole island's vibrating. Okay. So it's important for us to understand no, I just don't want to go, okay, this is what happened. Because it's important for you to make your own mind on this. This is the atoll structure of Moruroa, okay? So, an atoll, the solid part of the atoll, which, if you want, which comes from a volcano, okay? It's the brown dark here. That's rocks, okay? It's made of basalt, okay? If you want, when you look at the high islands, this is the rocks you see on high islands in the South Pacific. Okay? This part has sunk, and then the coral reef has grown. All this yellow bit here is mostly coral or sand. Okay? The yellow top, no. So if you see, it's important to look at the depths, more or less, okay? If you look at the depths, coral can go right to 600 meters. Okay, at 600 meters, there are no more live coral, okay? They are dead, they've been accumulating for years, okay? And these are the very fragile part of the island. And you have the only hard coral, if we say it, we can't say it hard, it's the Dolomites. It's a bright, the light color here, not yellow, but light brown. And these are sedimented coral, and it can be very hard, okay? And then you have the transitional formation here. This is a mixture of coral and rocks, you know. So it's porous. The water can flow through all this easily. Even in the rocks here, the water can flow, but the flow is slower. Okay? So water still grows. It does make the difference about explosion underground here and explosion underground if it's under a mountain, for example. Because here it's always saturated with water. So you have water flowing up all the time. So when you look at this map, and here, this map, you see when you are in the lagoon, underneath the lagoon where a test has been done, you have this structure. So in the, say, first 200 meters, you have, it's mostly sand in the lagoon, okay? Sand and some coral debris. Live coral is only on the, where, no, on this part here, where we are, no, where we have the emerged part of the island. It's here, okay? So you see that you more or less, when you come here under the rim of the island, you have, you reach sort of 400 meters. It's mostly coral, okay, carbonate. It's important to have those numbers in mind, because most the test, normally they make tests at 1,000 meters, but some tests have been done at 500 meters. And so when you're 500 meters here, you close to the fragile part of the island. And here, this is a map showing how it happens. The explosion. So they dig a borehole, 1 meter, go down right to more or less 1,000 meters. And then you have the chimney where the explosion occurs. Okay? It happens there. And you see on this map, this has been, it comes from this publication here, Fairhurst et al., 1999. It's a scientist from University of Minnesota who studied the case. Okay. So where RC means everything in that area, and this circle here, everything is just crashed down or melt after the explosion. But around here you can, well, if you go further, almost 400 meters away from the explosion, you have all fractured rocks around there. And the only way where it's supposedly, it's not, there's no change, deformation of the rocks, is that area where it's written elastic. No, elastic means that when it moves, but it doesn't break it. It can't move. But we'll see after that it does break it. So this is, you see, this is at 1,000 meters. The radius of destruction of the rocks is about 400 meters. So now, like I say, we see another picture later. Some of the explosions are made at 500 meters. So here are, here again the vertical scale of the picture we talked about earlier on. And here are all the sites of explosions on the atoll in Moruroa. Now, it's more than 130, okay, explosion there. You see all the holes they built. And you have, now the cold color here, no, the red one are the most powerful, is they just say, you have different sites. I just want you to keep in mind two sites, because we're not going through all those sites. Okay, the one area one, that's underneath on the carbonate side. Okay, on the side of the island, and site 4, which is here, which is also underneath the rim of the islands. Okay. Yeah, because if you look at why site 1? Because later we'll see that it's the part of the reef has collapsed there. Okay, and the area 4 is because here are, I say, hypothetical distribution of underground test in test area 4. It's hypothetical because this guy have done the studies and the French government requirement to know, to study the stability of the atoll. Okay, his report is available. It's in English. You can read it, but it's quite long. It's a lot of science in it. Here's 700 pages of that thing. I didn't read it all. So here you have, you see all the, it says hypothetical because he did his study without the French giving him the information. And the French government has asked him to do this study. And in some way, I don't understand. They're asking him to do, maybe it's really independent, but here are the position of all the bombs in area 4. Okay? And you see, okay, white one is, no, those white ones are less than 5 kilotons. Okay, 1 kiloton is that's a unit used for a nuclear bomb. It means it's the explosion of 5 kilotons of a 5 kiloton bomb. It's equivalent to 5 kilotons of TNT. Okay, is that TNT you're saying here? So it's the same unit. If you want explosion of in Hiroshima is 16 kiloton. Okay, so it's more in this green area, the one that's been used on Hiroshima. So the green one, and you see that first before the white one, some of them are really close to this. I mean, it's 500 at 500 meters. So it has some impact. You see the circle around is the extent, according to them, of the fracture damage. Okay. The green one is lower than 20 kilotons. And then it goes like this. The blue, 80 kilotons, we have one. And we have 4 red ones. That's the limit imposed, I think, by all the countries for underground test. They could not exceed 150 kilotons. But actually, we don't really know if it's 150 or how low is it compared to 150. So when you see this alignment underneath the island in the coral, underneath the coral, it's easy to imagine that there will be some damage on the island. Like we see here. So what happened? Consequences of that is the sinking and collapsing of reefs. On this side here, you see the reef, you have big fracture on the reef there. And in this part here, those islands were supposed to be above sea level. They're sinking. And one effect of the explosion I haven't said is when there's an explosion on top of the well where you have the explosion, and then you have all this, the soil that's on top that will just fall down. So it makes a hole. Even on land, that happens as well. So fracture part of the reef, and that's why part of the reef now is under survey. But we'll come back to that afterwards. And the part of the reef that was sinking is mostly, you see the color bit here in green and red. That's risky, and it's below sea level when it's red. And this photo has been, it's that part on top here, the area 1. And you see here, okay, on these photos, okay, that's just look at this one, okay. And this photo here, you see the reef here, and then there's a continuation here. And here it has disappeared. The reef here just collapsed about 2 to 3 kilometers. So that already happened. But there's more coming. But when, we still don't know, and nobody knows actually. In Fangataufa, there was no explosion on the, underneath the emerged land. Most of the underground test has been done in the middle. They all above 80 kilotons. Okay, they're not plenty, but what the result of those explosions is this: even though it's in the middle of the lagoon, on the reef you see fracture zone like this. Yeah, that shows you the risk we can have on atolls when you have underground tests. It's different, and the difference with those underground tests carried on continent and in mountains, the big difference is that these rocks are saturated with water, and water is still flowing through those rocks. And even if they say that when an explosion happened, all the material that was in the explosion is just cemented, because they say that the rocks would melt and cemented. But the structure of the rocks here is an island. It's not that clear, because they say when the island is formed, you have layers, and a layer 1 meter, and so between those layers, water still can go through. And this is what we can see even on land in Tahiti. When you have water coming down from even if it's the basalt is very hard rock, the water is still flowing through. So here, water is still going through. So now, so this is the, if you want, underground test has that effect to destroy mechanically the land, okay? But the risk of this, if part of the coral reef collapse, is the radioactive matter that was imprisoned in those wells will be easily accessible to water and might leak and come and pollute the whole environment of the South Pacific, not only in Tahiti. So we talk about that a bit now, because you know radioactivity pollution, because it comes from, as well, from atmospheric test and underground test, okay? And you know that plutonium has a half-life of 24,000 years. So it means a very, very long time. Once you have plutonium somewhere, it stays there. I mean, we won't even be there to look at it, to disappear. And actually, yeah, I wrote that because one of my students asked me, "Oh, sir, I'd like to do a project on nuclear waste." I say, "What about that project?" They say, "Yeah, I'd like to know if there's any way to get rid of it." They say, "There's no way at all." I'm a physicist, sorry, I've forgotten to tell you. There is actually no solution to the problem. We just hide it somewhere. You know, dig big holes, put them in, cover them, or some countries have just thrown that in the ocean. If you go to Northern Europe, you have plenty in the ocean as well. So, and you will see that. I'll show you a map later that the South Pacific, it's not that clear. It has also been used as rubbish dump. So radioactive pollution, okay? The first thing, like I told you, we have atmospheric tests happen in those atolls. Not only in these atolls, some of the atolls are in the Pacific by other nations, other big nations. So the effect will be the same. If there's, this is the pollution of the lagoon after atmospheric test. This has been, the measurement it's quite recent, like I say, 24,000 years. This is from 1998. And the explosion happened in the last one, in 1974, okay? And you see in the lagoon here, the red, we just concentrate on the red bit, okay? The red bit, the red here is very high, it's 1,000 becquerel per kilo of sand, if you want. For us to be the norm, to be intoxicated, we need a lot, maybe 100,000 becquerel. But this is 1,000 per kilo of sand. And it is a lot in terms of quantity, because it's the lagoon is, you've seen the thickness of the sand is about 200 meters, 140 to 200 meters in the lagoon. And the volume is big. And that has been, this is a pollution from the atmospheric test. And it hasn't changed, and it's just moving around, because on atolls, when there's a storm, the sand just moves around, as long it doesn't go through the passage. So some might come out to the ocean. Okay. So this, what you observe this is Moruroa on the right there, and you have Fangataufa here. Okay. You see the red spots here. So we'll talk about it after about climate change, but what happens if the reef collapses? All this one will be released to the ocean as well. And we can say the same for the where other countries have, I mean, like the US and the Marshall Islands in Bikini, the same, because most of the atmospheric tests, we have this deposit of radioactive material in the lagoon. In Christmas, it'll be the same as well, where the British have done theirs. Because that's a direct pollution from the test. And you also have the nuclear waste, because they always have, before they do the explosion, they enrich the uranium, and then you have all this waste. And here, this is, in Moruroa, this is Moruroa. In those blue area here, this is where they dump the waste. All the radioactive product, they just dump it in the sea. And here, this island, this is the base for the military, is 500 kilometers away. And they also dump some rubbish there, the nuclear waste around this island. And when they left, they throw all the trucks in the lagoon, but they're cleaning it now. So they really don't worry about, it's not they worry the environment, the military, I have to say. So this one, actually we don't know how much they throw there. But why would, so you have then, pollution from atmospheric tests that goes straight in the sun, in the lagoon. You have the nuclear waste, all those radioactive products that are not used for the explosion, that they don't take that back to France, of course. It's just dumped in the sea. And now you have the nuclear waste from the borewell, because the underground test. Because sites of boreholes are used as storage of radioactive waste. So when they do their test, and then you still have a bore, and then they just dump everything in there. And then they cover it with concrete on top. But like I say, the problem is that the water is still flowing through the whole island. So we have more or less an idea how many barrels has been stored in those boreholes, about 11,000. But I cannot guarantee this number. And most of the sites are located in fragile and fracture zones. It's usually in the coral reef. You see all along here, along the atoll, those are the sites they've used to dump all the waste. And the big question behind that is the stability of the reef. If, like you've seen, we have those fracture zones, and I've shown you that part of the reef has already collapsed. And if the reef collapsed, so all this waste is free to leave the site. So the risk of pollution is very high, just from those two islands. I haven't talked about the rest yet. Yeah, but you can see here how dramatic that can be for not for us only. Not for us Polynesian, but for all of us on this planet, because the South Pacific stays one of everybody's saying the non-exploited yet, but it's strongly exploited actually by fishermen. Yeah, that's conclude my part on the test, and I like to talk now about the sea level, the climate change. Yeah, before going to climate change, I just show you this photo. They already built that wall. before climate change came out. And on this sign here, well, it's written in French and Tahitian that nobody should go in this area because of risk of flood. So this wall is to protect the area. That shows that the atolls were already sinking here. So they know already the risk, what will happen if there is a sea level rise. And a cyclone, there was a cyclone in 2011, and so I've shown you that map with plutonium in the lagoon, and some of the plutonium has been spread around the lagoon. So, but we don't know if that plutonium has come to the ocean. We have no idea, because we actually cannot go close to these islands. You'll be shut down. They shot at you. And so what will be the effect of climate change? Okay, that's a big thing. I think you have a lot of oceanographers around that can talk about that better than me, even though I'm an oceanographer myself. The impact of sea level rise, so we know that if there's global warming, the sea level is rising, okay? But how fast, it's very difficult to say, actually, because the error is still big between estimation given by models, okay? Only models can give you what will happen in the 100 years. But measurements, the last measurements made by satellites on the last 20 years shows an increase which is about 3 millimeters per year. Okay, but it's increasing. But the effect, some islands are feeling the effect, like Tuvalu, and also recently I just read a paper before I came on the Marshall Islands, where the risk of wave can flood the island. Okay, so the sea level, the level of the sea is rising in some area, and mostly in the West Pacific. In the risk of rising sea level in Moruroa is when we have an El Nino event. Okay, the water is just balanced back to the east, so we can have that problem this is why we have this 2011 cyclone in Moruroa. So the impact of sea level rise is those accelerate erosion. Okay, because it's easy to imagine that you go to the beach and then you take sand and then you put it in the water and then it's quickly flattened. Okay? So erosion will be fast if the island, mostly those islands, if covered by sea. I mean, like as I say, that the limestone rocks, those limestones, they just disappear quickly with sea level rise, and they'll be propagated in the ocean. In this case, there's a risk of collapse, and on this map here, you see the black line here? That's the part that might fall on Moruroa. So we know that, the French government knows that, the scientists who made this, who've been there to do the survey, knows about that. So actually the island is under survey. When they're monitoring what will happen. Because if that bit of the island falls, so there is a danger of tidal surge. I mean, it's just a tsunami. And so people living on nearby islands will have problem, because as I say, most of the islands around here, they just at the sea level. No, they're atolls. So we can have a tsunami, and that's why this part of the island is surveyed in Moruroa. Not to stop it, because we can't stop it. To hope that we have time to warn the people living around. It's a hope, because no one there is a tsunami arrives. We've seen what happened in Japan, in Fukushima, the tsunami. And I have to tell you, Japan is the best in surveying the earthquake. They have the best equipment in the world. And the network is far better even than the one around California. So they really are top for the survey, but they did not know that an earthquake, when it happens, happens. And a landslide, it's the same. We don't know. So there's sort of survey, maybe to reassure people that we can't always warn you when it happens. But the problem here, after this, the problem is that we don't know when it happened, but we know it. The scientists who want to survey this area, they know that it will happen. It will happen. The island might collapse. Not might collapse, will collapse, part of it. So the risk is the collapse, and if that part collapses, and then you have all the wells, boreholes they made for their test, and it's more accessible to the water. So another leak to the ocean of the radioactive waste. So climate change, we say it's a big risk for pollution for this whole South Pacific. Not only here. Yeah, because why for the whole South Pacific? Because this is the map showing all the nuclear test sites and explosions in the South Pacific, in the Pacific. So you have the French one here, Moruroa Fangataufa, the one we were talking about. Some of the tests, the Malden and Kiribati, Malden is, I think it's a US, no. Kiribati is the Kiritimati, is Christmas Island now. I mean, it was Christmas Island. This is the 30 tests from the British. Johnston is the US, and Marshall Island is the US. And you have 2 in Japan, but that wasn't a test. And you also have in Australia atmospheric test. In Australia, it happened on the land, so there's no normally. The relationship with climate change or sea level rise is low, and there's no real relationship between those two. But for all the others, because the tests in the Marshall Islands happened on atolls as well. So the lagoon is polluted, and I know that in Marshall Islands as well, the nuclear waste, they just bury it, buried, if you can say it, bury. They put it on land and then they cover it with concrete. It's one way to bury things. So it's on the surface, at sea level, at the sea level. So all those islands are polluted. So that's a good big question. What will happen what's the impact of climate change on all these sites? What will happen of all this? Because I show you the map of Moruroa and Fangataufa. The inside in the lagoon, it's polluted. So that'll be the same for Christmas. That'll be the same for island. Because on the other islands, there is no survey. We have some survey here because there was a fight, a struggle with the French government, and then they sent the International Atomic Energy Agency to come and survey, to do some measurements, because only one measurement has been done in those islands. So I will stop here and then leave it to you. So the sea level rise is a big risk for contamination of the South Pacific. Not only South, on the Pacific. And the sea level rise in the South Pacific, what should be done actually is really a radioactive inventory is necessary. Because even when I have some data from Moruroa and Fangataufa, but we don't have all of the information about those atolls. And we don't know much, even worse for Enewetok and Bikini. How many weapons or whatever, military waste, I call it like this, excuse me, has been thrown in the lagoon. We don't know. And Christmas, it's the same. And the Christmas, the British have tried to clean the island. I think they collect back their truck, they throw in the lagoon. But it's what's very superficial. We have the Malden and Johnston. And Hawaii also is known for mostly this military site where they use radioactive bullet. And that's on the main island, Oahu. And the underground test of Moruroa Fangataufa is a special case because the soil is saturated with water, so water is still flowing through. So even if they say that when the rocks melt, it will completely isolate the radioactive matter there, but water still can go through and matter will get to it. And the big question about this contamination problem is the pollution and ecosystem. You know, I just read a paper from French people, when the pollution and radioactivity is low, and if they want to know if there is really radioactivity pollution, they just look at the fish or any animals living in the environment, because the fish concentrate a lot of radioactivity. So this is one way to test, to check if the area is polluted or not. So now you imagine now if we release radioactive matter in the environment, so most of the living creature in the environment will absorb it. And us as well, human being. But that we can't see it. That's why we always see pristine water like we see here. We can't see it. And we only see it on the next generation. Because we all know that a radioactive effect has an effect on our gene, on our DNA. So the new generation might have problems. And for our case, actually, there is no survey. We know that the number of thyroid cancer has increased. But we could never get that number because most of the doctors come from France. And in the past, most of the doctors were military doctors. And so it's sort of secret number. But we know today that a lot of people are dying of cancer. But surely like here, and then people always say, oh no, it's not due to that, because we eat a lot of tin food. That's one excuse they give us because of tin food. But we do eat a lot of fish, though, because the main source of protein in French Polynesia, South Pacific, is fish. And the other things I never talked about, when those atmospheric tests happen, where all this waste that comes from the bomb, where did they go? Because it all spread around South Pacific on all islands. We more or less all polluted. I have one of my friends who has been measuring in the sediment in Suva the radioactivity, and we see that when it's the test, we recognize the test and then the sediment that happened when there was a test in the Marshall Islands. So it went further south as well. So the propagation of all this, but we don't really know about that. Oh, yes, and maybe one of the recommendations I haven't badly written here is to recognize the impact of nuclear pollution as part of the preservation of the environment of the Pacific. So that's one aim of this guy. I think it's also one aim of my government, my political party, I would say. My government, I don't know. Yeah, that's it. Thank you very much for your attention. Actually, yeah, Greenpeace has been helpful because we cannot go and complain in the United Nations because we're part of France, we're territory of France. So all report in the United Nations comes from France. But since last year, and we've been reinscribed on the list of countries to be decolonized at the UN, and we can go now straight away to talk about it. Because we cannot, before that, we couldn't complain because the French will take the thing and say, no, I can't sue myself. So, and France has the right to veto everything as well. Don't forget, UN is big brothers, and they have the right for vetoing. So we don't have many help. It's mostly meeting people like Holly, other people, and then meeting friends. And then we had a chance to be in one of our government has been sensible to this problem, and took it first in our own assembly in Tahiti, and then the one around the South Pacific. So maybe if we have a joint action now with Marshall Islands, because they've been putting that on the table, because on the forum in the South Pacific, they are all in the states of the South Pacific where they meet every year. So every country comes with one topic that would like to raise or to be taken, and through the forum it can go to the UN. Because you have in this forum independent states that can take the business. But outside we can't do it. Impossible.